Okay, so welcome to section 7.1, which is oblique triangles and the law of sines. So oblique triangles and the law of sines. So let me make an ampersand. And the law of sines. Okay, so let's consider a triangle ABC. Triangle ABC. That is not a right triangle. So something like so. A, B, and C, with opposite sides little a, little b, and little c respectively, and height h. Okay, so let's consider angle A. Do you agree that if I look at the triangle on the left, where height h is a side, do you agree that sine of A will be opposite to angle A, which is h, divided by the hypotenuse on the left side triangle, which is c? So when I take this expression and multiply through by the denominator c, basically I'm cross multiplying, and I solve for h, I get that h can be written as c times sine of angle A. Okay, now let's look at, what color should I? Green. Angle C. So we can do the same thing for angle C. So sine of C. Now let's look at the right-hand side triangle. Do you agree that the side opposite C is H? And the hypotenuse of that right-hand side triangle is A? So once again, what I want to do is I want to cross multiply by the denominator A. And so when I do that, what I get is that height h will be equal to now A in orange times sine of angle C. But the height h is equal to the height h. Agreed? Anything is equal to himself. So what that means is I can take C times sine of A and set it equal to A, little a, times sine of angle C. And then what I can do with both sides of this equation is I can divide off by both A and C. So let's divide both by A, and let's divide both by C. Whatever I do to one side of an equation, I can do to the other. So on the left, C's reduce, and on the right-hand side, the A's reduce. So what this gives us then is that sine of A divided by little a is equivalent to sine of C divided by little c. Okay, so I believe we did this earlier in the semester. So what this is the law of sines. So the law of sines. The law of sines. Okay, so let's let triangle ABC with opposite sides little a, little b, and little c be given. Then we have the law of sines as follows. We have that sine of angle A divided by little side a is the same as sine of angle B divided by little side b, and that is the same as sine of angle C divided by little side c. Okay, let's note, actually let's do the note in this color. So note the reciprocals hold true, or the reciprocal identities hold true. So the reciprocal, identities hold true. So that is, i.e., it est little side a divided by sine of angle A is the same as little side b divided by sine of angle B, which is the same as little side c divided by sine of angle C. So we can take the reciprocal and it is still a true identity. Let's also note that there are two cases in which the law of sines cannot be used. So the law of sines cannot be used in the cases when all is given is either number one, side angle side, or number two, side side side. So if this is the only information you've been given, we can't apply the law of sines because we won't have enough information. So let's do an example applying the law of sines. Okay, so use the law of sines. To solve the following triangle. Solve the following triangles. Okay, so for number one, let's say we're given that the measure of angle A is 30 degrees. The measure of angle B is 45 degrees, and the length of side A is 12 times the square root of 3. Okay, so what I'm going to do is I'm going to try and create a triangle that looks something like this. We'll see. No, not drawn very well. Actually, it's going to be pretty bad, but I'm trying. Let's see. Something like this. So let's call this A, B, and C. So I'm given that the measure of angle A is 30 degrees. I'm given that the measure of angle B is 45 degrees. So it should be easy to find the measure of angle C. So the measure of angle C will be 180 degrees minus 30 minus 45. That turns out to be 105 degrees. So this is 105 degrees. That's terrible. Let me write that a bit better. 105 degrees. Okay, what else is given? I was given that little side A measures 12 times the square root of 3. So I need to find little side B and little side C. So hopefully I can use the law of sines to do this. So for example, if I wanted to find, say, little side B, well, I can use the reciprocals to the law of sines. I know that little side B divided by sine of angle B, I can set that equal to little side A divided by sine of angle A. that is little side B. Let's see, where should I do this? Might not have enough room. So little side B divided by angle B is opposite, so that's 45, so sine of 45 degrees. And I'm going to set that equal to A, little side A is 12 root 3. So 12 root 3. And sine of angle A is 30 degrees, so sine of 30 degrees. Okay, so now should I cross multiply at this point? Sure, let's go ahead and cross multiply by sine of 45 degrees. So we get that little side B will be equal to 12 times the square root of 3 times sine of 45 degrees, all divided by sine of 30 degrees. Okay, well, luckily those are all on my unit circle, so I can do that fairly easily. So this becomes 12 root 3. Sine of 45 degrees, of course, is the square root of 2 over 2. And that's all divided by sine of 30 degrees is 1/2. So what color? That's 1/2. Okay, so the 1/2s reduce, and I get that B is going to be 12 times the square root of 6. Okay, so now I've solved for side B. The remaining thing to solve triangle ABC is little side C. Okay, so before we do that, let's note something. Little side C is going to require, and let me actually do that in purple. The opposite angle to C is 105. So let's note something about 105 degrees. So note 105 degrees. Well, that's 45 plus 60, right? So therefore, if I were to evaluate sine of 105 degrees, that's really sine of 45 degrees plus 60 degrees, which of course is sine of the first, 45, times cosine of the second, 60, plus sine of the second times cosine of the first. So what do we get? Well, sine of 45, of course, is the square root of 2 over 2. Cosine of 60 is the x-coordinate, so that's 1/2. Plus sine of 60 is the longer one, so it's root 3 over 2. And, of course, cosine of 45 is the square root of 2 over 2. So we get that sine of 105 degrees is going to be root 2 plus root 6 all over 4, and that should look familiar. Okay, so now going back to we have that sine, what do I want to find? Little side C. So little side C, where am I going to do this? Little side C divided by sine of capital C will be equal to, let's use little side A again, what color was A? It was orange, okay. So little side A divided by sine of angle A. So this will be little side C divided by sine of 105 degrees is equal to, little side A was 12 root 3 divided by sine of angle A was 30 degrees. So once again, I can cross multiply to solve for C. So sine of 105. So I get that little side C is equal to 12 root 3. Let's do sine of 105 degrees divided by sine of 30 degrees. Okay, so little side C will be equal to 12 root 3. Well, sine of 105 we found to be quantity, the square root of 2, plus the square root of 6, and all of that over 4. And sine of 30 degrees, of course, is 1/2. Okay, so in the denominator, 2 goes into 4 twice. And then bringing that into the numerator, 2 goes into 12 6 times. So we get that little side C is equal to 6 square root of 3 times the quantity, square root of 2 plus the square root of 6. And you can just leave it like that. So now we've solved for all 3 sides of this triangle and all 3 angles. So let's do another one, just one more in this short video before I stop for this first part of section 7.1. Let's say we're given the measure of angle B is 45 degrees. The measure of angle C is 60 degrees. And the length of side A is 7 times the square root of 2. Okay, so let's see how I can do this. 45 degrees, 60, something like so. Okay, so let's call this A, B, and C. I'm given that the measure of B is 45 degrees. Given that the measure of angle C is 60 degrees. I'm given that side length A is 7 times the square root of 2. Okay, so the first thing I'd like to find is the measure of angle A. So do you agree that the measure of angle A should be 180 degrees minus 45 degrees minus 60 degrees? So I claim that that's going to be 75 degrees. So the measure of angle A is 75 degrees. Okay, so now I need to solve for, what color should I use? Let's use green for little side C. Let's use yellow for little side B. Okay, so let's start with little side B, shall we? So little side B divided by sine of capital B is equal to, the only little side I have given is A. So little side A divided by sine of angle A. Okay, so we have an issue, don't we? And the issue is that angle A is 75 degrees. So let's note something. "75 degrees is actually 45 degrees plus 30 degrees. So sine of 75 degrees can be thought of as sine of 45 degrees plus 30 degrees. So that's going to be sine of the first, 45 degrees, times cosine of the second, 30 degrees, plus sine of the second, 30 degrees, times cosine of the first, 45. Okay, so what do we have here? Sine of 45, of course, is the square root of 2 over 2. Cosine of 30, the longer of the two, is root 3 over 2. Plus sine of 30, the shorter, is 1/2. And cosine of 45 is the square root of 2 over 2. So what do we get for sine of 75? Looks like we get the square root of 6 plus the square root of 2. Well, that's exactly what we got for sine of 150. So equals to sine of, sorry, not 150, 105. Okay, well, anyways, getting back to where we were, which was, let me just copy and paste. We wanted to solve for side B. So I know that side B, maybe move that over one. So now I can plug in finally. So this will be B over sine of, what was the measure of angle B? It was 45 degrees, so sine of 45 degrees is equal to little side A, which was given as 7 root 2. I don't like that square root. Divided by sine of angle A, and of course angle A was a 75 degrees. Okay, so I can cross multiply to isolate B, so let's multiply by sine of 45. So we get that little side B is equal to 7 root 2 times sine of 45. So let me do that in orange. Sine of 45 degrees, all divided by sine of 75 degrees. Okay, so plugging in, what do we get? We get that little side B will be 7 times the square root of 2. Why are my square roots looking so bad today? Times the square root of 2. Sine of 45, of course, is the square root of 2. Divided by 2. And sine of 75, well, that was quantity, the square root of 6, plus the square root of 2, all over 4. So that goes into the numerator. Okay, so what do we have? Now that 2 goes into 4 twice. So we end up with B being equal to 7. Well, the square root of 2 times the square root of 2 is 2 times 2 all over the square root of 6 plus the square root of 2, which gives us B, little side B, is 28. Pardon me. Divided by the square root of 6 plus the square root of 2. And I've solved for side B, so now I need to solve for side C. Okay, so that's just side B. So little side C over sine of angle C will be equal to little side A divided by sine of angle A. So that is C divided by sine of, well, what was angle C? Angle C, oh shoot, it was in green, was 60 degrees. So let me make this green. So sine of 60 degrees. And that's equal to little side A, that was given as 7 root 2. So this is 7 times the square root of 2 over sine of 75 degrees. Okay, so I want to cross multiply. Let's do sine of 60 degrees to isolate C. So I get C is equal to 7 times the square root of 2 times sine of 60 degrees, all divided by sine of 75 degrees. Okay, so what do we have there? So we have 7 root 2. Sine of 60 degrees is the square root of 3, all divided by 2. Sine of 75 degrees, well, sine of 75 was the square root of 6 plus the square root of 2. Square root of 6 plus the square root of 2, all over 4, so that goes to the numerator. So what do we have here? We have 2 goes into 4 twice. So we get C is equal to 7 times the square root of 6 times 2, all divided by the square root of 6 plus the square root of 2. So what we have then is 14 times the square root of 6 all over the sum square root of 6 plus the square root of 2. Okay, and I'll continue with this section in the next video.